Okay, today, guys, we're going to go to 8.5. That's where we're going to prove that triangles are similar. Let me just check one thing here. Sure we're good. Okay. Proving that triangles are similar. Not going to be real long on the notes here. I'm just going to, I know we got a lot of repetition at our warm-up. We probably had our warm-up yesterday. So I'm going to go right down to our side similarity theory. Okay, you know you've got a side postulate for showing that two triangles are congruent. Here we're not saying congruency, we're saying that they're going to be similar, meaning they're going to be in proportion. All right. So basically, what they're saying here, if you had triangle ABC, okay, triangle, you want to prove triangle ABC is similar to triangle XYZ. We would have to make sure that our sides here were in proportion. Okay, so AB would have to be in proportion. If AB is in proportion to XY, and then YZ, okay, YZ is in proportion to BC, okay, or I'm sorry, BC on top, and this one, big to small, BC is going to be in proportion to YZ. Okay, so we're going from the bigger triangle to the smaller triangle. And finally, you would have ZX right here and CA. So you would have CA in proportion to ZX. Notice our last one to the first one, last one to the first one. And again, big to small. We're all going big to small, big to small, big to small. You could do small to big, but you would have to do the same the whole way through. Okay, so if all these are in proportion, in other words, if you have fractions and they reduce to the same fraction, then this is going to be two similar triangles that we're looking at through the side similarity theory. Okay, that would be proportional by, or similar by side. If you have each side in proportion to another side. Okay, so that's your first theorem that we're looking at here, proving similarity. Next one we're going to look at is the side angle side. Okay, side angle side theorem for similarity. Right? And on this one, okay, we obviously know that you have an angle here that are congruent. Okay, so if the angle of one triangle is congruent to an angle of a second triangle, we have that right here. Okay, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. A couple of things we have to look at here. When they say side angle side, remember, including these sides. Okay, so if we have an angle, this is an included angle, including these sides, there would be these two sides here. Okay, so in this situation, angle U is congruent to angle N. Okay, that's your angle. And for this to be congruent through the side, or to be similar through the side angle side similarity theorem, RU, okay, we're going big to small, would have to be in proportion to DN. Okay, and UN would have to be in proportion to MC. Again, going big to small. But like I said before in the previous one, you can also go small to big as long as you're consistent the whole way through. Okay, so if this was the case where you had your angle and the two included sides, angle, and the two sides that are included there, okay, you have your included angle and your two sides, included angle and your two sides, this is going to be similar through SAS, okay, side angle side, right? That's the side angle side similarity theorem. Down to example, we're going to look at examples 2 and 3 here, okay, before we deal with one, like example 1. That's going to be more towards what we're going to see a little bit later, okay. So our example 2 said they want to know if triangle RST is similar to triangle PSQ, okay. So RST, that's the big one here. We want to know if this big triangle here is going to be similar to PSQ. Okay. Well, one thing you definitely have, you have angle S, okay, the angle right here, PSQ, you can call it by 3, angle PSQ. That's right here. It's going to be congruent to itself because they both share that angle. And you write that congruent to angle RST. Okay, it's going to be congruent to angle RST. So you have your angle, that's your included angle there, and you have the sides on the outside. You want to see if they're proportional. You want to see if if you want to see here, if SR, okay, big SR, okay, is going to be in proportion to SP, okay? And when you do this, one thing you want to make sure you do is if we go SR, okay, SR big, that's actually going to be this whole side right here, okay, SR to SP, okay, SR in proportion to SP. And then you're going to have TS, okay, in proportion to QS. Right. Now you're basically just going to fill in the different values and see if you end up coming up with the same reduced fraction. Okay. So we're going to get SR. Now be careful. This is going to be end up being 12 plus your 4, that's 16 over SP, which is 4. Okay, the big side to the small side. All right, we know that SR right here, second to the first, and SP, second to the first. So we look at different ways to line things up. And we want to see if over here, TS, which again, make sure you don't just say 15, it's 15 plus the 5. This whole thing is going to be 20. Okay, so TS is going to be 20. Probably should have wrote over here. This is going to be 16. Okay, so you're going to end up having TS, which is 20. All right, and we're going to put that over QS, which is 5. And we can see these are in a proportion of 4 to 1. 4 goes into itself once, goes into 16 4 times, 4 to 1. 5 goes into itself once, goes into 24 times. So they reduce down to the same proportion, okay? And the two angles are going to be congruent here, okay? Your included angles are going to be congruent. They're actually the same. It's the reflexive property for angles. They're the same angle, okay? So this is going to be, we're looking at 2. We proved that triangle RST is similar to triangle PSQ. Similar to triangle PSQ. And that's our similarity symbol. Okay? And it's by SAS. Okay? for similarity. So that's for example number 2. Again, proving that 2 of the sides are going to be in proportion and the included angle is going to be congruent. Angles have to be congruent, sides have to be in proportion. Okay. And then finally, we're just going to find the value of x. And with this one, you can just put x, if you go big to small, okay, x over 12, big triangle, small triangle, is going to end up equaling 63 over 9. Okay. And if we end up solving for that, probably what you want to do here is, equals, and then up twice. Probably what you want to do here is reduce this fraction. 63 over 9 reduces down to 7 over 1. Make life a little bit easier, and you have x over 12. So all I did was I just reduced this fraction. Okay, 9 goes into 9 once, 9 goes into 63 7 times. And that easily gives you an answer. X times 1 equals 12 times 7, x equals 84. Okay? So that is your answer for x, and that's it for 8.4. Tomorrow we'll be having a review, and then Thursday we'll wrap up our last day before our remote spring break, and we'll have a quiz on Thursday. I'll keep up to date on your schedule, and that'll go over everything that we're going to be